Hello everyone, welcome to MindSpan Education. So far we are looking at the independence of random variable. Now in this video we will be looking at what happens to expectations when we have the independence. You will see we will learn one more property regarding this expectation when we have the independence. Before that, let me recall you few of the properties of this expectation. So we have already seen that if we have a linear function of a random variable and if we try to find the expectation of this, then that would be same as you first find the expectation of this random variable x and apply the same function to this expectation. So if you observe here the linear function here, this is the random variable. We are multiplying this random variable to constant a and we are adding some constant b to this, right? So if you want to find the expectation of this, what you can do, simply find the expectation of this random variable x and apply the same function. I mean to say, you apply the same constant or multiply the same constant to the expectation and add the same constant b to this expectation. You will get the expected value of this linear function or a right. So but this is not always true. We cannot say always that the expectation of a function will be same as finding the expectation and applying the same function. This will not be always true. This is the exceptional case where this is true, since this random variable is a linear function. But in general we cannot say that the finding the expectation of a function, let's say this function is a function of two random variable x and y. So you find the expectation of this function, or you find the individual expectation of this function of this random variable and apply this function. So this will not be always true. But we have seen when we have a linear function of a random variable, then in that case either you find the expectation of this function or you first find the expectation and apply the function, then both will be equal. But in general this is not true. We have seen this, right? Let's say if you have x square, then you cannot find the expectation of this x square and then apply the same function, right? In that case this equality will not hold. In case of more than one random variable, we have seen one more linearity property. Let's say we have this random variable x, y and z, and if we want to find the expectation of the sum of these random variable, in that case that would be equal to the expected value of x, expected value of y, expected value of z and their individual sum. And these properties doesn't require any kind of independence requirement. If you have independence or if you doesn't have the independence, these properties will always hold, right? So we have already seen these properties regarding the expectation. Now we will learn one additional property when we have the independence. So let's say that random variable x and y are independent, then the property is that if you find the expectation of the product of this random variable x and y, then this expectation will be equal to the product of the individual expectation of this random variable x and y respectively. Let's verify this one. How we can verify? We can just use, so this is what? This is nothing but a function, right? We can make use of the expected value rule. So expected value rule is nothing but if you have a given function, you can apply the expected value rule. So let's assume that this is a function that is x times y, right? And we can make use of the expected value rule to find the expectation of this random variable, find the expectation of this function, right? So that would be equal to this function. What is this function? Gx, and gx is x times y times the probability, and in this case it will be joint probability, right? Because we are talking about the two random variables at a time. So it will be the joint probability of this random variable x and y, right? And this thing needs to be sum over all the possible values of x and y, right? So this is how we use the expected value rule to find the expectation of any function. We can proceed further. What we can do, so this summation is over y, so whatever, or so since these two random variables are independent, so what will be this joint probability? So this joint probability, how we can write? That joint probability will be the product of the individual product of these marginal probabilities, right? We have seen that the definition of the independence, right? So we can write like this, and the other thing will be as it is. Now what we can do, we can simply you see this summation is over y, so in that case these x and these terms will be constant, so we can put these two things out of this summation. So summation over x, and we will put x outside of summation of y, and we will put this marginal PMF also out of this summation of y, right? And we will left over with this PMF of random variable y, marginal PMF for random variable y. And now if you observe, what is this and what is this, right? So this is the expected value of random variable y, and this is the expected value of random variable x times this expected value of y, right? So we have verified that if we have these two random variables that are independent, and if we want to find the expectation of their product, in that case if these two random variables are independent, then their expectation would be the product of their individual expectation, right? And also you can think like this also. Let's say instead of this x, you will have some function of x, so some function will also be a random variable, right? So let's say you have this function of this random variable x, and also this function of this random variable y, right? Random variable x and y is independent, then their function will be also independent, right? First of all, you will have to understand that this function will also be a random variable. This function will depending on this random variable x, and this function is depending on random variable y. And what we are saying that these two random, if these two random variables are x and y are independent, then whatever the function, these will be also random variable and these will be also independent, right? So you can just extend this derivation also, and you can directly, like if you have the function of these random variable x and y, and if we want to find the product of their expectation of these two functions, then their expectation would be the product of their individual expectations. Right. So if you want to verify this, you can proceed the same way how I have proceed. You will be able to do that. Next video we will see what happens to the variance when we have the independence. That is all in this video. Thank you so much.